Hey folks, welcome to my channel number 10. Today we have a problem on finding the limit of a series, and we have the problem on our screen. Limit n tending to infinity. Show that limit n tending to infinity 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 and so on. The nth term as n tends to infinity represented as n into n plus 1. Show that the limit of this series is 1, right? I want to draw your attention to each of these terms and let me write it down. Let's write 1 divided by 1 into 2, right? I think this is can be rewritten as 1 divided by 1 minus 1 divided by 2, right? So this is our first term of this particular series, and let's look at when we write the second and the third terms, are we able to express it in a similar format, right? And what is 1 divided by 2 into 3? It's nothing but 1 by 2 minus 1 by 3, right? And similarly, I have 1 divided by 3 into 4 can be written as 1 divided by 3 minus 1 divided by 4, right? I hope you folks are with me. All that we're doing is we are rewriting each term in the series, and I'm telling you why we are doing this, right? And likewise, when I extend this to 1 divided by n into n plus 1, which is my nth term, right? It is nothing but 1 divided by n minus 1 divided by n plus 1. Right? So any term in this particular series can be represented as 1 by n minus 1 by n plus 1, right? And let's say, for example, n equals 1, then we have the first term in the expression, which is 1 minus 1 by 2, which is nothing but, it is this expression, right? Let me highlight it. So this is my first term in the expression, right? And similarly, I have my second term here. And similarly, I have my third term here. And as n tends to infinity, I can represent my nth term as 1 by n minus 1 by n plus 1, right? So now what we've been asked to find is the sum of each of these terms, which is represented by 1 by n into n plus 1, is equal to 1. So when I sum this up, right, what that I get is an equation of this fashion, right? So let's write the limit as it is, n tending to infinity, and I'm going to rewrite this in the manner that we expanded, right? So the first term is nothing but 1 minus 1 by 2. Second term is nothing but 1 by 2 minus 1 by 3. And the third term is nothing but 1 by 3 minus 1 by 4. And likewise, I go on writing this until n tends to infinity, which is represented by 1 by n minus 1 by n plus 1, right? That makes it a lot simpler because we know that I am in a position to cancel minus 1 by 2 and plus 1 by 2, and similarly minus 1 by 3 and plus 1 by 3, similarly minus 1 by 4 which with plus 1 by 4, which will be the first part of my fourth term of this particular series, and likewise I go on till 1 by n, right? So I will be left with 1 minus, I'm going to write this here again, 1 minus 1 divided by n plus 1, right? And what's that? As n tends to infinity, we have the second part of this expression coming down to 0. And so we have 1 minus 0 is 1. And there you have the answer for this problem. So I hope you found this content useful. Please do subscribe to my channel and support. Thank you.